See here friends, there is a small correction in this. That is, instead of -2, I took plus, right, -4 I took. Anyway, right, my V output +2 it is. Then if it +2 comes to the right hand side, it becomes -2. Instead of writing -2, I wrote -4. This is what I did everywhere. Let me correct it. Okay. Here it should be -2. So here it is -2, and V output is V in by 3 minus 2 by 3, and here also -2 by 3 and -2 by 3. So the first breakpoint becomes -4 volts, and second breakpoint is +4 volts. Okay, now coming back to the question, and a voltage signal 13 sin omega t is applied to the circuit with ideal diodes is shown in the figure. Okay, the breakpoint values of the transfer characteristics are -4 and +4 volts. That's it. Okay, so even though this 10K resistor is present, what you can see is the breakpoints as -4 and +4. Okay, see, if this 10K is not present, our breakpoints might be -2 and +2. Because of this 10 kilo ohm, the breakpoint values are increasing, right? Anyway, instead of -2 and +2, we are getting -4 and +4. In addition to that, if this 10K is added, okay, that is not disturbing our breakpoint values. That's it. This is the correction in the problem. All right, you can see this correction from the previous video. Now, coming to the next question. For the circuit shown in figure, VI is a sinusoidal voltage of 6 volts peak amplitude, 60 volts peak amplitude. Assuming ideal diodes, the output waveform is given by. What might be the output waveform? You see, if this 15K is not present, we know what might be the answer. Okay, output minimum is 15 volts and output maximum is 35 volts. 15 to 35 is the expected answer. Okay, what is there any effect of this 15K? We need to check it. The first point here is, anyway, input is less than 15 volts. Maybe it is starting with 0 or negative peak, whatever it is. Actually, we vary the input from negative peak to positive peak. Meanwhile, various possible cases we need to take. Okay, so case 1. Let us take the case 1. D1 is on and D2 is off. Output 35 volts, 15 volts, 20K, 15K. Anyway, it is on, short circuit. Input and output. What is the output? 15 volts. That's a very simple thing. Even though we have this 15K, it doesn't play any role because entire current goes in this direction. Of course, diode is directed upwards, so current will go in anti-clockwise direction. Done. So this is valid for input less than breakpoint 1. Above circuit is valid if V input is less than breakpoint 1. Okay, take the second case. That is both D1 and D2 off. 15 volts, 35 volts, V output 20K, 15K. Input and output. What is output? It is equal to input. This is valid for input. It looks like input greater than 15 volts and less than 35 volts. Means if the input is in between breakpoint 1 and breakpoint 2. Above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. Next, case 3. D1 off and D2 on. If the input is greater than 35 volts, it looks like, then D1 is off, D2 is on. This is on. What is our output? It may be 20K and it is 15 kilo ohms. Input and output. What is output? 35 volts. Now we can consider this. Above circuit is valid if V input is greater than breakpoint 2. So at breakpoint 1, output is equal to 15 volts, also equal to input. Implies our breakpoint 1 is 15 volts. At breakpoint 2, output is equal to input, also it is equal to 35 volts. Implies breakpoint 2 is equal to 35 volts. Then what about our final result? If you take this, output minimum is 15 volts. If the input is less than breakpoint 1, output is equal to 15 volts. And if the input is in between breakpoint 1 and breakpoint 2, that is 15 and 35, output is 35. If the input is above 35 volts, output is 35. Okay, and if the input is again in between 35 and 15, output is equal to input. Input is below 15 volts, then output is 15. Like this, we can see the final output waveform. So, which option is correct? Option A. Very simple one. So, we have some 15K connected in addition, but is it influencing our breakpoints? No, not at all. See the things. Next, if V gamma is given, then we can write accordingly. We will write it. But anyway, this 15K is not disturbing the breakpoints. Next question. For the circuit shown in below figure, Vi is a sinusoidal voltage of 60 volts peak amplitude. Okay. Assuming ideal diodes, determine the maximum diode currents ID1 and ID2 respectively. What about ID1 and ID2 maximum values of those currents? Okay, simple. Previous problem only. What they are asking, instead of asking the breakpoints or the waveform or the transfer characteristics, they are asking the currents. Okay. So when can you see ID1 is maximum? I said input less than breakpoint 1, D1 is on, D2 is off. Less than breakpoint, okay. At the same time, when will the current ID1 is maximum, if you see, when input is at its lower level, minimum value, then cathode will be at much negative potential compared to anode. Okay, we can see the maximum current. Suppose when input is equal to 60 volts peak amplitude means we input minimum, that is minus 60 volts. Anyway, that time diode E1 is on with maximum conduction, right? Then ID1 is maximum. How to find it? When if we input is 60 volts, minus 60 volts, then definitely D1 is on and D2 is off. It acts as short circuit. 15 volts, input is minus 60 volts. Anyway, here we have one more resistor, D2 is off. This is ID1 maximum. ID1 is maximum when input is minus 60 volts. And now current is possible here through 15K. Okay. It is 20K and this is 15K. What about ID1? It is 15 minus of minus 60 by 20K. So 75 by 2, it is 3.75 milliampere. 7.5 by 2. Okay. So if you look at the options, okay, A and C, both places you can see that. Okay, fine. Let us find ID2 also. Okay, here I am writing it just to save some space. Next, if V input is equal to maximum, V input maximum, that is 60 volts, that time D1 is off, D2 is on with maximum conduction. Then ID2 is maximum. So what about the equivalent circuit then? Okay, then how ID2 will flow? This way. ID2 maximum. ID2 max is equal to 60 minus 35 by 20K plus 15K. 25 by 35 into 10 power minus 3. Okay, if you take it so, anyway, 5 by 7 I can write. 5 by 7 means 7 7 cents, 0.714 milliampere. So option A is correct. ID1 and ID2 maximum. That's it. Okay. This is how we can do this. For the circuit shown below, if Vi is equal to 20 sin omega t, the transfer characteristic plot is. What about the transfer characteristics of this given circuit? Okay. How do we do this? Suppose input is okay 20 sine omega t less than it may start from negative peak minus 20 volts onwards, minus 20, minus 19, minus 18, minus right 17, 16, so 0 up to 0. What happens? Initially D1 is off, no doubt about it. What about D2? Once D1 is off, is there any voltage that is possible here? It acts as open circuit. Then there is no voltage possible here. Simply it looks like a T network 10K, 10K, 10K. And there won't be any voltage here, means there won't be any voltage. D2 is also off. Both D1 and D2 are off. When input is at its negative peak, we can take it. So case 1, both D1 and D2 off. If so, what is the equivalent circuit we get? V output. As far as this circuit is concerned, what is the output? Simply 0. Okay, output minimum is 0 when input is at its negative peak. Let me take this is valid till a particular breakpoint. Okay, input is starting from negative peak and it is raising. It looks like as long as input is negative, D1 is off. Once D1 is off, automatically D2 will be off. Okay. So above circuit is valid if input is less than breakpoint 1. It looks like some 10 volts, whatever it is. We do not know. It looks like. Okay, case 2. D1 is on. Maybe G input is positive, above 0 volts like that. Maybe 1 volt, 2 volt like that. D1 is on. Right, okay, suppose here, if I give some 2 volts, D1 is on. But from 2 volts, is it possible to get a voltage here more than 10 volts? Impossible. So, still D2 remains off. So, case 2, D1 is on and D2 is off. So, the equivalent circuit is this way. Now, if you look at this circuit, how the current flows, entire current flows in this direction only, and no current flows through in this direction. Okay, this 10 volts is no way connected to the circuit. So what about output? Output is equal to V input by 2 or V input by 10K plus 10K into 10K kilo ohm. It is V input by 2. Okay, how long this is valid? Till the voltage at this point reaches 10 volts. Okay, let it be. That is the breakpoint 2, I can say. Here and here the same voltage we can see as no current is possible through 10 kilo ohm. Okay, above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. You can write so. Next, case 3. Okay. Further, you are increasing the input so that what happens? D1 is on, D2 is also on. Once D2 is on, what about the output? D2 acts as short circuit and output is equal to 10 volts. Okay. So, both D1 and D2 on. If so, 10 volts, we output 10 kilo ohm, 10k and 10k. What about the output? 10 volts. This is valid for input greater than breakpoint 2. Okay. Now let us find the two breakpoints. At breakpoint 1, output is equal to 0. Also, output is equal to input. Implies breakpoint 1 is 0 volts. We input by 2, sorry. Okay. Initial value of the output is 0. Right. Next, at breakpoint 2, output is equal to input by 2. Also, it is equal to 10 volts. Implies breakpoint 2 is equal to 20 volts. Okay. Then, if you draw the transfer characteristics, initially the output is 0. This is one line. Next, output is equal to input by 2. Slope is 1 by 2. And another one is output is equal to ten volts. So we can understand the breakpoints. This is breakpoint 1, initially 0. Next, output is equal to input by 2. Breakpoint 2, it is 20 volts. Next, output maximum is 10 volts. When input reaches its peak amplitude, positive peak amplitude, that time output reaches 10. Once the input falls, just whenever input is 20, that time only diode D2 is on. When input falls below 20, immediately D2 becomes off. Because the input is 20 sine omega t. When input reaches its peak amplitude, at that instant, D2 is also on along with D1. Later, D2 becomes off. And when input falls below its peak amplitude, falls below 0, D1 also becomes off. Okay. So this is how we can see the transfer characteristics. So looking at the options, okay, see, if you look at options, anyway, option B is out of, right, right, out of the things. Coming to A and C, compare A and C, output maximum is 10, okay, and breakpoint is also 20. Oh, excellent. And initially both the diodes D1, D2 off. Oh, D1, D2 on. It is wrong. Next, from 0 to 20 volts, D1 on, D2 off. Correct. After 20 volts, both D1, D2 on. Correct. So option A is correct. Transfer characteristics are looking same, but looking at the status of the diodes, option C cannot be taken. Option A is matching properly. So this is how we can do this problem. Next one. A triangular voltage waveform Vi of t is applied at the input to the circuit of figure. Assuming the diodes to be ideal. Okay. Determine the output voltage and neatly sketch the output waveform superimposed on the input Vi of t and label the key points. Okay, what about the output waveform and breakpoints? That's what they are expecting. Some triangular wave is superimposed on this particular circuit. Okay, so right, once you give such kind of a signal to this circuit, what about the result? Anyway, when input is 0, that time what happens? When input is 0, is there any possibility for D2 to conduct? Its anode is going to 0 and cathode is going to 7, D2 is off. And what about D1? Anode is at 0, cathode is going to 5 volts, so D1 is also off. Both D1 and D2 are off. That is our first case, case 1. D1 and D2 are off. It is not mandatory that a particular diode has to conduct. It all depends upon how the diodes are kept and how the circuit is. We just vary the input from negative peak to positive peak or minimum value to maximum value. What are the possible cases we take? So as far as the very first case is concerned, if input starts from 0, then both D1 and D2 are off. So what is the equivalent circuit then? Okay, again I need to check it. Okay. Point 0.5K, 5 volts, 1K, 1.5K. Output, input. Is it possible to take output is equal to 5 volts? No. Why? Because there is a scope for the current to flow in this direction. It's a simple network. Once you see the network, you can't take output is equal to 5 volts. If this 1.5 kilo ohm resistor is not present, absolutely output might be 5. Okay. So what about the output then? V output is equal to 5 volts by 1 kilo ohm plus 1.5 kilo ohm multiplied with, that is the current I can write, multiplied with 1.5K. So it is 3 volts. Okay. Then above circuit is valid if V input is less than breakpoint 1. Okay, it looks like 5 volts. We do not know. It looks like 5. Okay. Next, case 2. You are increasing the input above breakpoint 1. So that what happens? Maybe it looks like some 5 volts like this. If input is 5 volts or more than 5, then D2 is still off and D1 is on. Okay. So D2 to conduct, input should be more than 7, something like that. It is appearing so. We do not know the exact value. So if input is more than 5, it looks like D1 is on and D2 is still off. Case 2. D1 is on and D2 is off. What is the equivalent circuit? One 1.5K, 1 kilo ohm, 0.5 kilo ohm input. This 7 volts is nowhere connected to the circuit. What is the output then? So this is our output. Let me take this as node X or node A, anything we can take. KCL at node X. What we can write? V output minus V input by 0.5 kilo ohm plus V output minus 5 by 1 kilo ohm plus V output by 1.5 kilo ohm is equal to 0. Further, I can cancel this K. It is a 2 V output plus V output plus 2 V output by 3 is equal to 2 V input plus 5. I hope you understand it straight away. So it is 11 V output by 3 is equal to 2 V input plus 5. Then what about V output? 6 by 11 Vi plus 15 by 11. Okay, some equation we are. How long this is valid? This is above breakpoint 1 and below breakpoint 2. So we are increasing up to what level? You have to raise the input to a level where D2 may also conduct. Okay. So that is the breakpoint 2. I can say above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. Okay. Next, third case. Both D1 and D2 are off. See, on. First case 1, both D1 and D2 are off. Next, D1 on, D2 off. Next, D2 is on. Once D2 is on, it acts as short circuit. What comes here? 7 volts. For 7 volts, what happens to D1? D1 still conducts. Okay, if the input is more than 7 volts like that, it looks like what exactly it is, we do not know. We have to find it. So, both D1 and D2 are on. So, seven volts. V output. So what is the output? 7 volts. How long this is valid? This is valid for input greater than breakpoint 2. So input is greater than breakpoint. Now let us find the breakpoint values. That's it. Is there any other case possible? No. Further, if you increase input, both are on. That's it. Right? That's the final thing. Then at breakpoint 1, output is equal to 3 volts. That is also equal to 6 by 11 V input plus 15 by 11. Implies, what about V input? It is 33 minus 15 by 6. So it is 3 volts. This is our breakpoint. It is not 5, it is 3. Okay, if input is less than 3 volts, then D1 is, both D1 and D2 are off. So case 1 means circuit 1 is possible if input is less than 3 volts. Why it is so? You can observe this. Here output is 3 volts. So, and D1, D2 is off, then D1 to, for D1 to conduct, the voltage here should be more than 3. I need not go up to this 5 volts because the voltage here is only 3. That's the interesting point in this problem. Okay, we'll check it. Okay, input is 4 volts, then how D1 can conduct, because its anode is looking like it's going to 4 and the cathode is going towards 3. How D1 can be on? Right, it is possible because of this 1.5 kilo ohms. That's the idea in this problem. Okay, next, at breakpoint 2, output is equal to 6 by 11 times V input plus 15 by 11. Also, it is equal to 7. Implies V input is equal to 77 minus 15 by 6. It is a 62 by 6. 62 by 6 means 10.33 volts, something like this, which is our breakpoint 2. Okay, we need to raise the input up to 10.33 volts, then only both D1 and D2 are off. It is not 7 volts. The interesting point here is breakpoint 1 is not 5 and breakpoint 2 is not 7. Breakpoint 1 is less than 5 and breakpoint 2 is more than 7. Okay, that is the effect of this 1.5 kilo ohm resistor. This is the idea. Right, anyway, based on that, with this slope, we can plot it. I'm not drawing all the waveforms because it is a descriptive question, right? My concern is how to solve this problem. Okay, we need not worry about these things. Okay, now just verification out of curiosity. I would like to cross check it, right? As the breakpoint 1 is 3 volts. So what happens if the input is 4 volts? Above 3 volts on value I'm taking. It looks like breakpoint 1 should be 5. It looks like, but it is not 5, it is 3. Let me take 4 volts or 5. Okay, anything above breakpoint I'm taking. Okay. Instead of 5, if I take 4, what happens here? Anyway, D2 is off. For all 4 volts, D1 should be on, right? It looks like, just I'm trying to do some verification. If V input is equal to 4 volts, then what happens? It looks like D1 should be off. Anyway, D1 also should be off, right? D2 is anyway off. D1 also should be off. Okay, but I'm saying D1 is on. If D1 is on, ID1 we can calculate it should be positive. Is it not so? Then okay, I said D1 is on. It looks like D1 should be off. Then see this. This current is ID1. So what about the output here? Anyway, let us take this as output and node X, KCL at node X. If I take it, V output minus V input is 4 by 0.5 K plus V output minus 5 by 1 K plus V output by 1.5K is equal to 0. Further, I can cancel this. And it is 2V output plus V output plus 2 by 3 V output is equal to 8. 4 by 0.5 means 8 plus 5, it is 13. Then what about V output? We have already seen it is 11 V output by 3 is equal to 13. Implies V output is equal to 39 by 11. So how much do we get? It is 3 point, okay, some 5 4 3.54 volt. It is not 3, it is more than 3. It looks like V output is. Then what about ID1? If that is the case, ID1 is equal to V input minus V output by 0.5K. Input is 4 minus 3.54 by 0.5K. Yes, it is positive. Our assumption is correct. So, even though we have here 5 volts, if the input is 4 volts, then also D1 is on. It's not like anode is at a lesser voltage compared to cathode. Why it is happening so? Because of this 1.5 kilo ohm resistor. Right? These are all for our understanding sake. We need not to do right all this in the things in the examination. Right, at the time of learning, to once you analyze these things in a detailed manner in the exam, you can do the problems confidently. Okay, this is one case. Right, I'm taking a value less than 5, right, and above breakpoint. Still, what happens? D1 on, D2 off. Correct. Case 2 is valid. Next, case 3, both D1 and D2 are on for input to be greater than 10.33. It is, that's the meaning of the second breakpoint. Okay, so what happens if I take input is equal to 8 volts? More than 7 I'm taking, but not going up to 10.33. Above 7 I'm taking. Okay, so if V input is equal to some 8 volts, 9, like this, 8 volts I'm taking. For 8 volts, it looks like D2 should conduct. Okay, anyway, D1 is on conduction. It looks like D2 is on. It looks like D2 is on. See, have been following a procedure of ID1, a calculation of ID1 and ID2. Right, for that particular value of V input, you can calculate the voltage at this point. That is another way. Okay, so verification means what you can do. If V input is in between breakpoint 1 and breakpoint 2, right, input is in between breakpoint 1 means 3 volts and 10.33. This is a valid circuit I'm saying. If so, what is the output you can take? If the output voltage, if you see, that is the voltage appearing at the anode of D2. Okay, if it is less than 7, absolutely D2 is off. Simple thing. Otherwise, we can, already we know the equation and we are calculating anode voltage of D2. Otherwise, if you assume D2 is on and calculate ID2, you will get negative. Any option you can take. It looks like D2 is on and you can calculate ID2. Right? Anyway, just I'm changing the procedure. It looks like D2 is on. Instead of that, as D2 is off, I mentioned D2 is off. Let us calculate. I want to check whether I'm right or not. So let us take it. So here what happens? D1 is on and D2 is off. Okay, if that is the case, what is the output equation? It is 6 by 11 into V input plus 15 by 11. Okay, so it is 48 plus 15 by 11. It is 63 by 11. Okay, directly I am writing here. Input is 8. 8 6 are 48. 48 plus 15. It is 63 by 11. 5 point something you will get. 5.74 volts. So the anode voltage of D2, right? If input is 8 volts, then anode voltage of D2 is at 5.74 volt. Cathode is at 7 volts. Absolutely D2 is off. Perfectly we are getting the result. See how much powerful processor I have developed. Okay, with who will calculate all these values, breakpoints? All right, trial and error method you can't do. You have an extraordinary procedure. You follow that, find the breakpoints. You will get it. These are all for our better understanding, cross verification of the results. Okay, so definitely anode voltage of D2 is 5.74 volt and cathode voltage D2 is 7 volts. 100%, I'm writing it, 100% D2 is off. No doubt about it. What we did is correct. If you assume D2 is on, calculate the current through D2 like what I did in the previous case. You can see that ID2 is negative. Okay, that's it. So the breakpoints are 3 volts and 10.33 volts. That's it. Look at this question. Assuming the diodes D1 and D2 of the circuit, not circuits, circuit, shown in the figure to be ideal ones, the transfer characteristics of the circuit will be, okay, RL it is given as infinite, means it is an open circuit. What about the transfer characteristics of this particular circuit? Okay, initially if the input is 0 or negative, what happens? D1 is off. And what about D2? If D1 is off, it acts as open circuit and it is a 10 volts 2K input, 5 volts. I'm just removing the load resistor. It is given as infinite. D2. Then look at the diode D2. Its anode is going to 5 and cathode is going to 10. So this is the only possibility of current to flow. Cathode is going towards 10, anode is at 5. Is it possible for D2 to conduct then? If I calculate also, what will be the current? Assuming ideal diode. ID2 is equal to 5 minus 10 by 2K. It is negative. No doubt about it. D2 also does not conduct. Okay. So both D1 and D2 are off. Case 1. Both D1 and D2 are off. Five volts. Then what is the output, friends? 10 volts. Output minimum is 10 in this case. Even though you have 5 volts, you need not bother about it. Okay. What is the first possible circuit? From the circuit, what is the output equation? That's it. We don't think much. We need not think much. Nothing to worry about. Okay. So here output is above circuit is valid if input is less than breakpoint 1. First breakpoint. Next, input is above breakpoint means here the voltage at this point is looking like 10 volts. For D1 to conduct, input should be more than 10. Okay, above breakpoint. It looks like 10. Let it be. When input is above 10 volts or above breakpoint, case 2. Above breakpoint, what happens? D1 becomes on. If D1 is on, what happens to D2? Okay, about 10 volts I'm speaking. There is no point of thinking at 5 volts because this is the possible circuit we are observing. Right, input is more than 10 or maybe 11 volts, 12 volts like that. For that, D1 is on. What about D2? Once D1 is on, the voltage along this line is more than 10, no? Then is it possible for D2 to conduct? No. Here, let me write it as D2. Okay. There is no scope for D2 to conduct at all in this problem. There is 5 volts is not at all coming as a breakpoint and D2 is not at all conducting. See the interesting thing in this problem. Okay, when input is case 2, D1 is on, still D2 is off. So, D1 acts as short circuit. D2 acts as open circuit. What about output? Output is equal to input. Okay, 2K resistor. Nothing to worry about it. This is a possible circuit. So 5 volts is not playing any role and D2 is not at all conducting throughout. For all values of input, there is no scope for D2 to conduct. Okay, this is valid if V input is greater than breakpoint. We have only one breakpoint, above and below. Breakpoint 1 we have, that's it. No more 2 breakpoints. At breakpoint 1 or breakpoint, output is equal to 10 is equal to input. Implies our breakpoint 1 is 10 volts. Now, if I draw the transfer characteristics, one equation is output is equal to 10 volts. Another equation is output is equal to input. So, what is our breakpoint? Only breakpoint 1 whose value is 10 volts. Input less than breakpoint, output is 10, and input greater than breakpoint, output is equal to input. This is an interesting thing. Don't expect like, okay, both D1, D2 should be off, D1 on, D2 off, D1 off or D2 on, or both D1, D2 on. It all depends upon how the circuit is given. Right? We can't look at all probable cases. Only few cases. It is not mandatory that all cases should be possible. Some may be possible, some may not be possible. Okay. That's why I always suggest stick to the basics and follow the procedure. Option A is correct. Okay. Next. Assuming the diodes D1 and D2 of the circuit shown in figure is to be ideal ones, the transfer characteristics of the circuit will be. Okay, now RL is given. Simple. Previous problem only with RL they have given. How do we do this? Procedure remains the same. The first case, when input is at its negative peak or negative, D1 is off. What about D2? Earlier, D2 was also off because entire current was going like this, if D2 conducts. But now a finite resistor is connected. When a resistor comes in parallel with diodes and all, we should be very careful. Assuming diode is on, calculate the current through the diode. If you get negative, then only I can conclude that D2 is off, otherwise I cannot. Okay, so this is D2. Anyway, I'm taking D1 is off, no doubt about it. For D2, whether D2 conducts or not, to decide that, I don't want to take any risk of assuming that D2 is also off. I want to confirm by calculating ID2 because RL is a finite value. Earlier it was open, now there is a resistor. We can't trust. It may cheat like anything. D1 is off, no doubt about it. And D2, I'm assuming D2 is on. And assume D2 is on. Okay. Then let us find ID2. This current is ID2. V output. Okay. So if D2 is on, what about the output? It is 5 volts. It is short circuit now. Output is 5 volts. Then as it is 5 volts, there might be some current flowing like this. Let me take this current is I1. I1 and ID2 are coming like this, and this current is I2. So what about I1? It is 10 minus 5 by 2K, 2.5 milliampere. And I2, it is V output by 1K, 5 milliampere. Absolutely. What about ID2? It is I2 minus I1, 2.5 milliampere. Our assumption is correct. See this. Right. When I started the diode circuits with the DC, I told when a resistor comes parallel with the diode, definitely we are not sure that diode will always conduct. There is, or diode may not, it's not like diode is always off. That influence of the resistor will be there. That's it. So our assumption is correct. So what I can write, this I can take that as case 1, right? Let me take this as case 1. Above circuit is valid if V input is less than breakpoint 1. Okay, we have got output as 5 volts and breakpoint, oh, it looks like 5. Let it be. Next, we are increasing the input above breakpoint. So as it is 5, the voltage here will be, output is 5 volts, means the voltage here will be 5 volts. For D1 to conduct, input should be more than cathode voltage. Okay, above 5 volts. If input is above 5 volts, D1 is on, maybe 6 volts like this. So if D1 is on, it acts as short circuit. So what is the voltage along this line then? 6 volts. If 6 volts is present here, what about D2? Immediately D2 becomes off. Okay, see the interesting thing. So case 2, I'm writing here. Once D1 becomes on, automatically D2 becomes off. So the equivalent circuit is 10 volts 2K 5 volts 1 kilo ohm input output. What is the output, friends? Input. And above circuit is valid if input is greater than breakpoint. Okay, it looks like 5 volts, maybe 6 volts, 7 volts, 8 volts, 9 volts, 10 volts, 12 volts, 15 volts, whatever it is. What happens? D1 is on only. And what about D2? The voltage along this line is above 5 volts. So there is no scope for D2 to conduct at all. That's it. This is my equivalent circuit and output is equal to input. Input may be 6 or 7, 8, 9, 10, whatever it is. Output is equal to input and D2 never conducts. So you will get only one breakpoint here. Or we can even cross at breakpoint 1, output is equal to 5. It is also equal to input. Implies our breakpoint 1 is 5 volt. Now, in this circuit, there is no point of looking at 10 volts. Is 10 volts coming into picture? Not at all. Okay, so now if I draw the transfer characteristics of this particular case, see how interesting the problem is. One case is output is equal to 5 volts. Another case is output is equal to input. And what is our breakpoint, friends? This is our breakpoint 1. Only one breakpoint you can see. Input less than breakpoint, output is 5. Input greater than breakpoint, output is equal to input. That's it. Is there any necessity to worry about 10 volts? No. Right? See the difference between the previous problem and this. Here, the 5 volts is not playing any role, friends. Right? It's not coming into the picture. Breakpoint is 10 volts, output minimum is 10, and later output maximum is equal to input maximum. But if I connect a load resistor of some 1K, then what happens? Right, in this case, in this particular problem, D2 never conducts. D1 conducts for input less than 10. D1 doesn't conduct for input less than 10. About 10 volts, D1 is on. And D2 always off. And there is no point of looking at this 5 volts as my output or breakpoint. And coming to the second problem, here by connecting a load resistor of 1 kilo ohm, initially D2 is on. Okay, we have seen. Later, once the input goes above the breakpoint, once D1 is on, automatically D2 will be off. Okay, and there is no point of observing this 10 volts as a breakpoint or output maximum like that. So very, very interesting problem it is. So don't think like some voltages are given in the problem means they have to appear. We do not know. They may be or may not be as breakpoints or output minimum or output maximum. We do not know. Okay. Look at this problem. The input voltage Vi to the two-level clipper shown below figure varies linearly from 0 to 150 volts. Okay. Assuming ideal diodes, the transfer characteristics are, they are asking to draw the transfer characteristics. Right. If you observe this initially, right, 0 to 150, okay, let us start our input with 0 volts. If the input is 0 volts, what happens? D1 is no doubt off. And what about D2? D2, its anode is going towards 100 volts and its cathode is going towards 25 volts. D2 will be on. So, first possible case is D1 off and D2 on. Case 1. 25 volts. Hundred volts. 100. So what is the output? Is it 100 volts? No. Is it 25 volts? No. Something else. What it is? We need to find. There is a current flow. Let me take this as I. What about this current I? I is equal to 100 minus 25 by 200k plus 100k. How much do you get? 75 by 300. So 0.25 milliampere. Okay. Then what about V output? It is I is flowing like this means. So V output is 100 minus I into 200k. Okay. So it is 50 volts. See, output minimum is 50 volts. You can see. It's not either 25 or 100. Something, well, some value in between we are getting. And of course, this circuit is valid if input is less than breakpoint 1 as usual. Input is going from 0 volts, 0, 1, 2, 3 like that. It may be 25 volts, whatever it is. We do not know. Anyway, once D1 is off, D2 is on, output is 50 volts. So how long this is possible? It looks like, anyway, right, it is short circuit, no? So 50 volts means it looks like input is less than 50 volts, then this is the possible circuit. Okay. When input is more than 50, then what happens? D1 is on and D2 is also on, because here, right, suppose it is some 55 or 60 volts, D1 on, and it short circuit, it is 60. What about D2? Its anode is going to 100 and the cathode is at 60. So still D2 is also on. Okay, so case 2, both D1 and D2 are on. So what is the equivalent circuit? Output is equal to input. Is it not so? And how long this is possible? This is possible, it looks like, as long as input is above breakpoint 1 and below 100. It looks like for D2 to off, right, cathode voltage of D2 should be less greater than 100 volts. So above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. Okay, both D1 and D2 are on and output is equal to input. Okay, done. Next, if input is more than, it looks like 100, more than 100, then what happens? D1 is on and D2 will be off. So still D1 on, D2 is off. Then how the current flows? The entire current will flow this direction then. Okay. So if input is more than 100 volts, maybe 101 or 1.1, we do not know exactly, it looks like, then D1 is still on but D2 is off. Okay, that's the meaning of it. Case 3. Still D1 is on and D2 is off. D2 is open circuit, 100 volts. I think it is 200k. Yes, 100k. We output. Input. What about the output? It is equal to 100 volts. This is true for input is greater than breakpoint 2. Input is greater than breakpoint 2. I'm not writing the exact value as 100. We have to check it. Now at breakpoint 1, output is equal to 50. Also output is equal to input. Means 100% breakpoint 1 is 50 volts. At breakpoint 2, output is equal to input also equal to 100 implies breakpoint 2 is equal to 100 volts. No doubt about it. So it's not like a 25 and 100. The first breakpoint is 50 and second breakpoint is 100. That's it. Okay, input is above 100 volts. D1 is still on but D2 is off. And input is nowhere connected to the output and output is equal to 100 volts. Okay, this is how we can do this problem. I'm erasing these things. Next, the input voltage Vi to the two-level Clipper circuit shown below figure varies linearly from 0 to 15 volts. Okay, the same problem only with similar problem. Assuming ideal diodes, the transfer characteristics are. Okay, what about the transfer characteristics of this circuit? Okay, again we start with input is equal to 0. When input is 0, see this. What happens to D1? Its anode is at 0, cathode is at 100. D1 is off. D2, its anode is at 0, cathode is going to 25. D2 is also off. Both D1 and D2 are off. Case 1. D1 and D2 are off. Then 25 volts, 100 volts, 100k, 200k. Input, output. Okay, then what is the output? It is 25 volts. Okay, the reference voltage we are using is appearing as your output. Okay, in the previous problem, output minimum is 50 volts we got. Okay, and anyway, we will draw the transfer characteristics or not here. Only breakpoints I mentioned. They asked you to draw the transfer characteristics. Sorry, let me write the transfer characteristics. Previous problem, friends. Output, sorry, it is output and it is input. One equation is output is equal to 50 and another equation is output is equal to input. And third equation is output is equal to 100 volts. Now we can see the breakpoints. Breakpoint 1 is 50. Breakpoint 2 is 100 volts. Output minimum is 50. Output is equal to input and output maximum is 50. This is how we can see the transfer characteristics. Even though we have this 25 volts, it is not coming into the picture. It's not mandatory. I forgot to tell that. Right. Anyway, coming to this. Now, in this case, we are able to see. Now, above circuit is valid if V input is less than breakpoint 1, maybe 25 volts. Okay. And how long? Alright, about 20, right? Less than 25. About both the diodes are off and output is 25. If the input is more than 25, then what happens? D1 is still off and there is a scope for D2 to conduct. Okay. So, case 2. D1 is still off and D2 to conduct. Output. Okay, so this is input. Now let us find output here. There is a current flow this way. So what is output, friends? It is V input minus 25 by 100K plus 200K. That is the current I can write. That is multiplied with 200K. That gives voltage across this 200K, for which I need to add 25 volts. That gives us the total output voltage. How much it is? It is 2 by 3 V input minus 50 by 3 plus 25. It is ultimately plus 25 by 3 we get. I'm writing it directly. So how long this is valid? Above circuit is valid for input above breakpoint 1 and below 100 volts. It looks like 100. We do not know. Because if the input is going above 100 volts, then there is a scope for D1 to conduct. That time what happens to D2? D2 still remains in on state only. Okay. So if you keep on increase the input above certain value, it looks like 100. We are not sure exactly whether it's 100 or not. Then D1 is on. What about D2? D2 still remains in on state only. Okay. So means above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. Next. If input is above breakpoint 2, both D1 and D2 are on. Okay, case 3. Both D1 and D2 are on. What is the possible circuit? $25, $100, $200K, $100K output. Input. What is the output of this particular circuit? It is 100 volts. How long this is possible? This is possible for input greater than breakpoint 2. So, above circuit is valid if input is greater than breakpoint 2. Okay. Next. At breakpoint 1, output is equal to 25, also equal to 2 by 3 V input plus 25 by 3. Implies input is equal to 25 into 3, it is 75 minus 25 by 2. It is 25 volt. Breakpoint 1. Okay, 25 volts only. If the input is less than 25 volts, then circuit 1 is possible. Case 1 is possible. Output is equal to 25. Okay, if input is more than 25, then D1 is still off, D2 is on. That is the second case. Right. At breakpoint 2, output is equal to 2 by 3 V input plus 25 by 3. It is also equal to 100. Then the corresponding input value is 300 minus 25 by 2. 275. 275 means 137.5. This is our breakpoint. It is not 100, friends. It is 137.5. See the interesting thing. Which means if the input is in between 25 and 137.5, case 2 is possible. It is not 100. Okay, it is above below above 100 and below, right? About 25 to 137.5. That time this is the possible circuit and the corresponding output equation. Okay, and input is above 137.5, then both D1 and D2 are on and output is equal to 100 volts. See the interesting thing here. Okay, so if I draw the transfer characteristics of this particular case, one equation is like output is equal to 25 volt, and another equation is like 2 by 3 V input plus 25 by 3. 25 by 3 means 8 point something. So it is like Y is equal to mx plus C. If you take V output is equal to 2 by 3 V input plus 25 by 3, it is like Y is equal to mx plus C. It is an intercept on axis is positive. So I can take it this way. And third equation is output is equal to 100 volts. Now breakpoint 1, 25 volt. Breakpoint 2, 137.5. You will check it. Every problem. If you, whenever I feel like you may get some doubt, I am cross verifying the result. Okay. Anyway, output is 25 and for less than breakpoint. In between breakpoint 1 and breakpoint 2, this is the equation. Input greater than breakpoint 2, output is 100 volts. This is how we can see the transfer characteristics. I want to cross check it. Means suppose my input is greater than 100 volts and less than breakpoint 2. Is it really so that D2 is D1 is still off? Okay. So let us take a value. Suppose my input is equal to 110 or 102 volts. Anything I can take it. Verification. If V input is equal to, I am just taking above 100 volts, 102. That time, if input is less than breakpoint 1 and breakpoint 2, definitely what happens? D1 is on and D2 is, sorry, D1, D2, right? Which one is taken as D1? D1 is off and D2 is on. No doubt about it. So, if that is the case, what is the output? 2 by 3 V input plus 25 by 3. So 2 by 3 into 102 plus it is 8.33 something. So how much do you get here? 3 3s 3 4s 34 into 2 68. 68 plus 8.33 76.33 volts. Okay, 76.33, which means in circuit 2, case 2, what about the anode voltage? See, if the input is 102 volts, okay, I will draw the circuit otherwise. Input is above 100, and what about the corresponding output? We are getting 76.33 volts. Means the anode voltage of D1 is at 76.33 and the cathode of D1 is at 100. Is the anode voltage less than cathode voltage or not? Even though input is more than 100 volts. Why it is so? The circuit is like that. What to do? Okay, this is the idea. And how long, up to what level, to when will D1 conduct? Means we have to see that output should reach up to, right, with this equation. With this equation, you keep on increase the value of input till the output reaches 100 volts. If the output reaches 100 volts, then anode voltage of D1 is reaching 100 or more than 100, then cathode voltage is at 100, then D1 becomes on. That time anyway D2 remains on, because the anode of D1, D2 is at a voltage more than 25. Okay, 102 volts, and its cathode is going towards 25 volts. This is the idea. So this is how we can conclude this problem. This is also one interesting question. Next, see this. The input Vi to the two-level clipper shown in the below figure varies linearly from 0 to 150 volts. Okay, same thing. Assuming ideal diodes, plot the transfer characteristics. What about the transfer characteristics of this particular case? Okay, suppose input is 0 volts. What happens to D1? Its cathode is going to 0 and anode is at 100. D1 will be on 100%. And what about D2? Once it is on, it acts as a short circuit. The voltage here will be 100 volts. Even though input is 0, the voltage at this point will be 100, for which D2 is also on. Input is 0, but both D1 and D2 are on. Okay. So, case 1. Both D1 and D2 on. What is possible? That's it. When input is at its minimum value, what is possible? What happens to the diodes? It looks like both are conducting. Okay. Then the equivalent circuit is 100 volts, 25 volts, 200K, 100K input, output. What is output, friends? 100 volts. Okay, that's it. And how long this is possible? As long as input is less than particular breakpoint. Looks like 100. Input is less than 100. D1 is on and D2 is also on. And output is equal to 100 volts. 25 volts is no way coming into the picture. Output minimum is 100. I'm starting with input at its negative minimum value, right? Maybe 0 in this case, because as it is varying from 0 to 150. Okay, so above circuit is valid if input is less than breakpoint 1. Okay. Next, above breakpoint, maybe greater than 100 volts. It looks like. What happens? D1 becomes off. Once D1 is off, what happens to D2? D2 still remains in on only because the input is more than 100. The anode of D2 is at a voltage more than 100 and its cathode is going to 25. So D2 still remains on only. Nothing happens to D2. Case 2. D1 is off and D2 is on. 100 volts. 100K, 200K input and output. What about the output equation? We have already seen this circuit, no? There is a current flow like this. I and I into 200K plus 25 volts is the output voltage. How much do you get? 2 by 3 V input. I am directly writing it. It is 25 by 3. And how long this is valid? This is valid for input greater than breakpoint 1. Okay, if you keep on increase the input, this circuit only remains, no? Is there any other circuit possible? 100, 110, 120, 130, 150, you go up to 150. It doesn't matter. D1 is off and D2 is still on. That's it. Which means above circuit is valid if input is greater than breakpoint 1. Is there any other breakpoint possible here? No, not at all. That's it. So at breakpoint 1, output is equal to 100, also equal to 2 by 3 V input plus 25 by 3. Implies already this case we have seen input is equal to 137.5 volt, which is our breakpoint. Means if I draw the, is there any other case possible? No. It's not like D2. There is no scope for D2 to off in this case. D2 is continuously on. That's it. And less than below breakpoint, below 137.5, D1 is on and D2 is anyway, both D1 and D2 are on. If input is greater than 137.5, then D1 becomes off and D2 becomes on. Okay. So if I take the transfer characteristics, one equation is like output is equal to 100 volt, and another equation is like y is equal to mx plus c. And what about the breakpoint? Only one breakpoint. It is 137.5. Input less than breakpoint, output is equal to 100. Input is greater than breakpoint, output is equal to 2 by 3 V input plus 25 by 3. That's it. This is the idea. Now students can cross check above 100 volts, maybe 102 like this. Is it right? True that D1 is becoming off. Absolutely. Okay, I said this is the circuit possible for input greater than 137.5. Okay, input less than 137.5, D1 is on. I'm saying we can cross check it. Verification. If V input is equal to 102 volts, then what happens? Both D1 and D2 should be on. Okay. Hundred volts. 25 volts output. Output is 100 volts input. So 102 volts. You can take 102, right? Just below breakpoint 2. My concern is okay. 100k, 200k. Then this current is ID1 and this current is ID2. First we can calculate this current as I. What about I? It is input minus output by 100k. It is 102 minus 100 by 100k. 0.02 milliampere. Okay. What about ID2? It is equal to V output minus 25 by 200k. Output is 100 minus 25 by 200k. 75 by 2. 75 by 2 means how much we get? 75 by 200. Okay. 0.375 milliampere. Sorry, 3.75 milliampere. Okay. And what about ID1? ID1 is equal to I plus ID1 is equal to ID2. Then ID1 is equal to ID2 minus I. I need not calculate it, or if I take it so also, it is 3.73 milliampere. That's it. Sometimes it doubts like this. Okay. So is it not so? Absolutely. What the circuit we have got, we are cross verifying. Is it true or not? 100% it is true. Okay, how long this will be true? Right, anyway, it continues till V input is less than 137.5. If input is 137, more than 137.5, immediately D1 becomes off, but still D2 continues to be in conduction. That's it. So the final transfer characteristics are same. That's it.